Hisham from Team 1, Sub-Team A. I'll be giving a quick overview of how Hossam and I worked to implement this task. We were supposed to develop the timer driver and use it to control the RGB LED brightness or blinking on the TVC board using a push button. So the system flow would go like this. Initially the RGB LED is off, and at each press of the button a PWM signal with a different duty cycle and the same period of 500 milliseconds would be generated on the pin of the green LED on the board. So at the first press of the button, the green LED would be on with a 30% duty cycle, but since the period of the PWM signal is quite long, so the LED would appear to be blinking with the off time noticeably longer than the on time. And at the second press of the button, the green LED would be on with a 60% duty cycle, so it would appear to be blinking with the on time just slightly longer than the off time. And at the third press of the button, the green LED would be blinking with 90% duty cycle. It would be on most of the time and just turn off very briefly at each period. And at the fourth press, the green LED would be off, and if we press the button again, then we would be repeating the sequence back from the top. So to implement the sequence, each of us implemented some drivers. For me, those were the GPIO button and PWM drivers. The GPIO and button drivers were already implemented in previous tasks, only needed some tweaks, upgrades, and maybe for the button to be compatible with the new timer driver. Then the PWM driver, I implemented it to use the timer driver that Hossam implemented to generate PWM signals on different pins with different duty cycles and periods. And then we went on to test the application together, which Hossam would be talking more about and about.
Hello everyone, this is Hossam Elwahsh. I was working on the general purpose timer driver as well as the LED driver and the application flow. For the GPT driver, it took me a while to finish all the required APIs. Okay, we have GPT init. Takes a void because we have a linking configuration that you can add the configuration that will be initialized. You can add up to 12 channels in this array. I'm just using 3 channels right now. For the interface, back to the interface, we have the init function, we have the start function which takes the channel ID, the delay value in time units, and the time units itself, which is an enum, whether it's in seconds, milliseconds, or microseconds. And then we have the stop API, takes a channel, stops it, and get elapsed and get remaining time, each of which takes a channel and a pointer to return the value inside of it. Also we have a set callback function that takes a channel and a pointer to the void function, that will be called. We have an enable notification API and a disable notification. You can use these to dynamically turn on off the callbacks that you already set before using this API. Okay. And these are the time units. These are the available channels, and these are the return status. Not supported Yeah, okay. In our in the stored API, it just takes a delay value and a time unit. There is no prescaler, a predefined prescaler or anything like that in the configuration. The timer API, the timer driver will automatically calculate the appropriate prescaler value as well as the count values. So if the requested delay is way over the allowed limit that the timer can use a prescaler for, it will return a not supported value. Okay, that's it for the GPT. For the LED driver, it's the same LED driver that we used in the previous tasks, so nothing changed. For the application, me and Alaa decided to for the requirements, it's required to change the duty cycles on the go whenever you press the switch, 30 to 60% to 90%. We decided to also add the different LEDs, red, green and blue, in which for every duty cycle, like 30% the LED will be red, for the 60% it will be green, and for the 90% will be blue, just to be able to quickly distinguish in which state the application is currently running. Okay, and we have the regular app init, app stored, and a private helper function called app next state, which stops the PWM for the current LED. Turn off the LED, go to the next LED color, adjust the PWM signal and restart it on the requested channel. Okay, enough about the code. Let's quickly move to the hardware. Let me connect the TVC real quick. We currently have the TVC on top of the Sprints kit, but just doing nothing more than that. Okay, give me a second. Okay, hardware is connected. Let me show you the TVC in action. Okay, I have the light dim to be able to see the LEDs correctly. Okay, maybe turn it a little. Okay, so this is the TVC, this is the blinking LED we have. It's also blinking the first LED on the ATmega32 board, but the code is running through the TVC itself. Okay, whenever I click the button, it will go to the next state, turn on the next color, that's an extra, and change the duty cycle. So click in here, it will switch to the blue, the second LED here, and the duty is now 60%. Clicking again, it will switch to the green one, 90% duty, and the third LED. Again, it will go back with 30% duty, blue, and green. Okay, thank you for watching.